So simultaneous equations part 2. Solve the following equations using firstly the substitution method and secondly the elimination method. Okay, if we call this one equation 1 and this one equation 2, for part 1 using the substitution method, we need to get either x or y by itself in either one of these equations to be able to sub it into the other one. Now, it is easier to do that with equation 1 because there's no numbers in front of the x or y. So looking at equation 1, is there a way that you can write x by itself in terms of y? So to do that, we can move the positive y over so that we end up with x equals 1 minus y, like so. Okay, and then because this is a substitution method, everywhere x appears in this equation, so everywhere that x appears in there, we are going to put 1 minus y into that equation. So 2 bracket 1 minus y plus 3y equals minus 1. Expanding the brackets, 2 minus 2y plus 3y equals minus 1. Now this becomes 2, now that would be plus y equals minus 1. And lastly, y would be equal to minus 3 because you minus the 2 over. So therefore, y equals minus 3. And because we are doing simultaneous equations, there is a solution for x and a solution for y as well. We've got y, we need to know x, so subbing in y equals minus 3 into here. So going back up to here, we have x equals 1 minus minus 3, which becomes x equals 4. And just make sure that you're really clear, therefore x equals 4 and y equals minus 3. That's your answer there. The elimination method. The elimination method, we can either add or subtract these two equations to cancel out either an x or y. Now, if we were to add these equations together, we would get 3x plus 4y equals 0. So x and y aren't cancelling. And if we were to subtract these equations, we would get x minus 2x, which is minus x, y minus 3y, which is minus 2y, and y minus minus 1, which gives 2. And again, they're not cancelling. So we actually need to multiply one of the equations by a number in order to get them to cancel. So, okay, so think, how can I make this x here look like 2x? What can I multiply it by? What can I multiply this x by to look like 2x? Well, the answer to that is, of course, multiply everything in there by 2. So I can just multiply that first whole equation there by 2. Okay, so then I'll get 2x plus 2y equals 2. And then, if I then subtract these two equations here and here, my x's will cancel out because 2x take away 2x is 0. 3y take away 2y is simply y. And minus 1 minus 2 gives minus 3. And we're already there. We've got y equals minus 3, which is what we had as our answer before. Okay, then we know that y equals minus 3, so we can put this back into our equation up here. X minus 3 equals 1. Adding 3 to the other side, we know that x, of course, equals 4. So therefore, x equals 4, y equals minus 3 is our answer for that one. It's just another way of doing it. It's up to you which way you want to do it when solving these equations. Example 2, solve these simultaneous equations using the elimination method. So x and 3x, they're not the same. Obviously, if we add or subtract, we're not going to get 0. But here we have 2y and 2y. So if we add them, 2y minus 2y will give us 0, so they will cancel out. Okay, so adding those equations together, x plus 3x is 4x. 2y take away 2y is going to be 0, and then 1 plus 5 is equal to 6. So therefore x equals 6 over 4, which we should know is 3 on 2, or 1.5. 3 on 2 is an acceptable answer. Okay, then using this to sub into one of our initial equations, doesn't matter which one, we just need to find out what y is. So if we have 3 over 2 plus 2y equals 1, subtracting 1.5 or the 3 on 2 over to the right, we get 2y equals minus a half. And then finally dividing by that 2 there, we will get y equals minus 1 over 4. So just being clear again, therefore x equals 3 on 2 and y equals minus a quarter are our two answers there. Solve these simultaneous equations. So once again, if we add these equations together, we'll get 5x there, and we would get minus y here, so they wouldn't cancel out. But if we subtract them, we would get minus x and 3y here, so again they wouldn't cancel. So we need to make this equation look like this bottom equation here. So calling this one equation 1 and equation 2. Probably the easiest one to do here is to make this y look like 2y. How can you make y look like 2y? Of course we can multiply it by 2. So if we do equation 1 times 2, we would get 4x plus 2y equals 12. Okay, and comparing that to equation 2 up here, I'll just write equation 2. We know that that's just 3x minus 2y equals minus 5. That's our equation 2 from before. And how can we make these disappear? Well, we can do that simply by adding them together. Okay. So 4x plus 3x gives 7x. 2y minus 2y cancels, and 12 minus 5 gives 7. Okay, finally dividing by 7. Those cancel out, so x equals 1. Substituting x equals 1 back into our initial equation. So 2 times 1 plus y equals 6. Solving that, it's a fairly simple one. We should get that y equals 4. So therefore x equals 1 and y equals 4. Okay, and that's it for simultaneous equations.